It'd be silver.
Let's do it like this. It's like I'm like a keyboard player.
I never thought you'd be so cool.
AC/DC. You got it?
I got it.
Hands up if you send a tweet. All right, come on, everyone.
You can retweet my tweet. This mic. I uploaded a file to my DVS.
All right. I'm going to talk about analyzing data out of MongoDB. So who here is in data analysis? Reporting, business intelligence. Good. All right. Good percentage. So real quick, what is business intelligence? What's analytics? I'm not going to read this to you. Simply, it means turning data into information. Data is something you store in a database. It's something you manipulate with an application. Information is actionable data. You take the data, you put it together, you do something with it so that a business person can make a decision. That's all analysis and business intelligence are. There are several categories of business intelligence. Reporting is pretty straightforward. Building reports, deploying reports. There's self-service business intelligence. That means there's a tool, probably a model that's been built over the data. It's in business terms. That allows a user to connect their application to the source data system and start dragging and dropping and build a report. Maybe you have dashboards, or maybe you just allow ad hoc access. Don't allow ad hoc access directly to the database, by the way. Not a big fan of that. Build some sort of abstraction there. There's also warehousing. Everybody's heard enterprise data warehousing. There's two distinct flavors of EDW. There's the Inman model that works really well with Teradata. That's about it. And there's the Kimball model, which is stars, snowflakes, which is facts and dimensions. A fact is a table that contains measures. Those are numbers to be aggregated, and keys that connect you to a dimension. Dimension contains attributes. That's how you slice data. So how many units did I sell 3 days ago? Units is what you're aggregating. Date is going to be what your dimension is. And then the definition of the product, definition of the SKU. That's another attribute. Analytics, that's kind of a loaded term. Typically what we mean by analytics is a decision support system, online analytical processing system. You might have heard cubes before, data cubes. And then you have predictive analytics and machine learning, which is on the far end of the data science spectrum. There's frameworks built specifically for that, for taking complex mathematical algorithms and putting them together in a model. You might train models, you might teach models how to learn on their own. You've heard the term artificial intelligence. That's what ML is. It's just the new iteration of AI. And then good old big data, another loaded term. Typically what people mean is, they'll say data lake. What it really is a data swamp or a data dump. Due to the reaction, everybody's dealt with that. When I do presentations on data lakes, I actually have a slide that has a picture of the floating garbage island. If you've ever seen that in the Pacific Ocean, it's about the size of Texas, literally. And then you have distributed systems that also comprise the big data space. That's where MongoDB fits in, the big data. It is a distributed database. So we could be massively distributed and have parallel reads and writes using something called sharding. Sharding is nothing but partitioning. Partitioning of data. But instead of doing a partition like you would in an Oracle or a SQL server, where the partition is part of a file group on a machine, and sharding, each shard is a machine. And you can add shard after shard after shard, and as you do, you're scaling linearly. So let's say with one machine, you're getting 1,000 ops per second. When your application gets to the point where, hey, I need 1,500 ops per second, you add another shard. Data is distributed across the 2 shards now. You're at 2,000 ops per second. And then as you grow, you just keep adding more and more shards. By the way, I'm open to questions throughout the entire presentation. So if you have questions, raise your hand up high. Yeah.
So about the sharding, so is there any mechanism like MongoDB can automatically add all the shards for you as the need arises?
So the question is, can MongoDB automatically add shards? I can use a tool called Ops Manager or Cloud Manager to add shards. So the automation piece is I've got a machine or set of machines or containers that have an agent on it. And with that agent, I can say, add these machines to my sharded cluster. And it'll add them. And then the balancer will start redistributing data. The automation, so let's say you're using a cloud platform and you want to be able to elastically scale up or down. That is not in there today. That's actually a machine learning algorithm that a friend of mine and I were working on in Palo Alto.
So the follow-up is, can I decrease the instances?
Yes. No, there's going to be data rebalancing. The thing to keep in mind is if you shard, the data is being distributed across these shards. So if you remove a shard, you need to move the data off of that shard first.
So is it a painful process or?
Yeah. Depends on the amount of data.
I will just execute a command and MongoDB.
I've done it before, I didn't find it that painful. Other people have done it and they found it painful. So good old DBA answer in advance. Question?
So you said sharding is like partitioning.
Yes.
In my Oracle world, partitioning is usually done using some kind of column or something. Is that the same principle in the sharding?
So the question is, in Oracle, when I partition, I am partitioning on a column, a value. And does that same rule apply in MongoDB? The answer is yes, it does. So there's three different types, and we're kind of taking a little side path here, but I'm happy to answer. There are three different types or ways of sharding with MongoDB. It is based on fields that exist inside of your documents. Once you've set a shard key, that's it. That shard key must exist in every single document within that collection. Thing to keep in mind also, we shard at the collection level, not the document level. Or, I'm sorry, not the database level. So you can have a database with multiple collections. Some that are sharded, some that are not. You choose the shard key. Two different algorithms. There's a hash, and we'll auto-generate the hash for you. You just choose a set of fields or a field to hash, and it'll auto-balance based on that hash. Or you can choose a range. The range that you define. Don't use time. Time is a bad shard key. Because it monotonically increases, right? You'll always be pushing data to your outer shard. That's bad. And then we have a concept of zones. A zone allows you to lock data to a specific set of shards. So imagine you've got data in a data center in the east, some in the west, some in the central, and some in Europe. But you want it to be one big database. You can use sharding plus zones to lock data into those locations. You can also use sharding to send data to different storage tiers. So you've got super fast storage, in-memory storage for information that you're accessing on a regular basis. Move some of it to slower disk, spinning disk, and some of it to cold disk. Okay. BI connector.
Just one question.
Sure.
That's regarding reporting. What type of tools are available for reporting out of MongoDB?
You're about to see. Great question. The question was, what kind of tools can we use to report against MongoDB? And the answer is a lot, a whole lot. So I'm going to cover those. So when it comes to business intelligence, there are tons of tools out there. We know the Tableaus, we know the ClickViews, we know the MicroStrategies, reporting services from the SQL Server perspective. Excel, probably the most popular one.
Yeah.
They all use one common method to connect to data sources, ODBC. So either tools can write native connectors to MongoDB, or we could build an ODBC connector for all the tools, which is what we did. That's what the BI connector is. So when we talk about business intelligence, self-service reporting, ad hoc, things like reporting services where you can do set up subscriptions, it's all through ODBC connectivity. So this graphic up here is a representation of the tool. I'm actually going to do a demo of this. The way it works, you have a tool, it connects via ODBC to the BI connector. Then you start sending SQL queries. Most of these tools auto-generate the SQL queries for you. You can write your own as well. As those SQL queries hit the BI connector, they're translated into Mongo query language. Mongo query language, I know there are several people here that have used Mongo. It looks quite similar to JSON, or I'm sorry, JavaScript, the functionality. It has the same methods as SQL. It's CRUD, create, read, update, delete. Then there's the aggregation framework that allows you to do things like sums, counts, min, max, standard deviation, group by, having. All the things you can do in SQL, you can do in MQL. So when we ingest SQL, we convert it to MQL. We push the aggregations down to the aggregation framework. And I'll show an example of that. And then we return the information back in a tabular format, because that's what ODBC understands. Question?
Is there a way to see the output, the MQL output, so that you can train your little SQL
Yes.
people into
Question
grown-up
is,
Mongo people?
is there a way to see the MQL output from the BI connector? The answer is yes. And I'm actually going to show that.
Okay.
I'll demo that.
Question, please.
Yes.
So this is kind of confusing a little bit because
If you connect like a reporting tool, well, this implies that you have a static schema because you have an abstraction layer.
What a good looking question. Okay. Statement. This implies that you have a static schema. And we just learned that MongoDB does not have static schemas. What gives? We have a tool that's part of the BI connector called the MongoDRDL tool. Document relational definition language. Yeah. Basically what we're doing is we're generating a YAML file. You point the DRDL, and I'll show this too. You point the DRDL to your database, it inspects it and it finds the collections, and then it generates this static schema for you. It looks like a relational schema. It's a metadata operation, so it takes milliseconds to do. Then you can go in and actually edit that file if you want. You can change the column names, you can change the definition, you can change the types of data. And you can generate multiple DRDLs for a given database instead of collections.
And can you go the other way around if I'm
Does it do the other way around?
Yeah,
No.
meaning I'm more of a relational thinker, and then
Right.
I'm tweaking or adding columns or something. Can it ingest?
Does it push down into MongoDB
Yeah.
schema? No, it does not.
Okay.
This is a one-way. It's a read only.
Okay.
So what this is going to allow you to do then is use the query language that you know, SQL, convert it to Mongo query language, and return information back. Is there a question?
Is there a performance hit by going through additional?
Is there a performance hit by going through this? Yes. How great is it? It depends. Do you have indexes? How big is your collection? What kind of queries are you running? Are you doing column or collection scans? So give me everything from database and then let me manipulate it in Tableau. Yeah, you're going to have a serious performance issue. But if you're selective, in other words, if you build reports, use indexes, and retrieve information so that end users can build their reports, or you have static reports predefined, performance is really good. It's actually excellent, especially with the latest version. Yes.
On the text search there, some of the traditional method is using like Solar Search or something.
Yes.
So there is no need for these type of appliances to if you deploy MongoDB.
So question, on the slide before it said text search, do we need Solar? The answer is we have faceted search built into MongoDB 3.4. So Solar, Lucene, Elastic, those are all faceted search engines. That's actually built into MongoDB in version 3.4, as is Graph. So if you're doing Graph functionality, that's also built into MongoDB.
So is MongoDB using the Lucene?
Is MongoDB using Lucene? No, it is not. It's got aggregations that are built into it. Okay, demo time. So I've got a MongoDB server running here. It's version 3.4.1, actually 3.4.0. I've got the MongoDB BI connector running inside of it. So I'm going to start a trace. Actually, first, let's look at the DRDL. So I had a database. I'll show you the databases. This is Compass, by the way. If you haven't seen Compass, this is a tool that's part of.
It's not showing.
Oh,
Definition language.
nice. Thanks for pointing that out. I would have just kept going. That would have been the demo, just a big slide that says demo. So this is Compass. I'm connecting to, get to crane my neck while I do this. This is the server that I've got running. Oh, seriously. And I'm going to use, this touchy, Airlines database. Within Airlines, these are my collections. You can see I've got document counts, average size, if I have indexes or not. So let's go in and, if you haven't seen Compass, it gives you a nice visualization of what's inside of your MongoDB instance. So here's all the documents. I can expand it into each one. If I want to see what the documents themselves look like, this is the actual document that's inside my database. So we've got 1.3 million docs. I did build indexes because I'm going to be doing reporting. I want this thing to be performant. So there's my database. If I switch over to my instance, that's the YAML file. I'm going to use that DRDL. I can come in and edit this thing. I can create multiple YAML files. Or DRDLs is what we call
What's the other acronym we use?
it. YAML,
YML.
YAML. Okay. This is how most people are going to connect to the BI connector. They're not going to know it's a BI connector. They're just going to have Tableau. See if somebody gets it. Nobody knows?
Yeah, use it.
What'd you notice?
MySQL?
MySQL. There is a SQL engine inside of the BI connector. It's not full version of MySQL.
Ah.
But we need a SQL engine. We have to ingest the SQL language. So we need a SQL engine. We can either write our own, or we can use something that's already out there. So it made sense to use something that's already out there. Okay, let me turn again. So then you get to see the pretty graphics inside of Tableau. We don't say ooh and ah. Right? Ooh, ah. You guys are good. Now the other thing I can do in here is that translation part. Let's cancel that. And I'm going to tail the log for the vagrant. Or not the vagrant, sorry, the MongoSQL process. There's a log associated with it. Okay, there we go. So now we're tailing the log. Switch back over to Tableau. And when I switch the tab down here, it's actually, going to a different report. So it's running a query. I ran the query in the background. This is real time, by the way. And this is what happened. So I've got, there's the group by down there. Jeez, you're touchy. It's so much easier to see on my laptop. Anybody see the SQL? You see a select up there somewhere. Oh, it's so hard to see.
Fifth line from the bottom.
Fifth line from the bottom. Oh, it's all the way down here.
Too far. Algebraizer. Now it's
Down.
10th line.
Yes, algebra.
Look for the big word, all caps, algebraizer, about a third way from the bottom.
Ah, there it is. There it is. Oh, jeez. I kept hearing algebraizer. It's like, what is that?
Algebraizer.
Oh, that's what it says right there.
There's the guy. Right?
So there's our select
Next
statement.
statement.
Select from table carrier as some group by one. And it turns it into this down here. EMQL. If you're not pleased with the syntax, there's the guy to talk to you back there. He wrote this.
As long as I never have to type it myself.
It actually does an excellent job of translation of SQL into MQL. It's probably gone.
So,
So we've
you
got-
you said you built connectors to various BI tools. Is one
Any
of them?
BI tool that's using ODBC. So I actually connected using the MySQL ODBC driver from Tableau to the BI connector. I could do the exact same thing with Excel. You do it with reporting services. I could do it with
Business
any tool.
objects?
Does it support ODBC?
I believe so.
Yes. Here's your answer. Question was, what tools supports this? The answer is anything that supports ODBC. This is MySQL Workbench. So I can just connect using MySQL Workbench and run select statements. While that's running,
Oh.
right here.
Now that that's up.
It allows the old SQL tools to use the new stuff.
Yeah. Clever way.
There's my result set. So obviously the results inside of MongoDB are not in a tabular format. They're in document format. The BI connector is retrieving them and returning them in tabular format because you're running a SQL statement.
How's the schema look like here? Can we see the schema?
Sure. What's the schema look like? It's right here. It's this table.
Yeah.
There's a bunch of tables.
So each one of those represents the collections.
Correct. It's pretty flat in this one.
Is it really the YAML representation? of
It
what
is
you
the
put in there,
YAML
so you can
representation that we're
manipulate?
seeing. That YAML file acts as, it's like views. There's no data persistent in the BI connector. I connect to it, I send SQL in, it gets converted to MQL and it comes right back out. Cool?
Cool.
We good?
Very good.
Awesome.
How many documents do you have in this particular?
I had 1.3 million documents in that collection,
Not too sure.
running on a little tiny virtual server.
And how many fields in each document you have?
Question, how many documents and how many fields? So we can go right back into Compass real quick. So my field, if I go into here, documents, 1.3, fields, a lot. A lot of fields. This is actually DOT information. So DOT.gov.
Tableau using a cover query when you ran this?
I did not use a covered query when I ran this. I did have indexes for some of them that did cover them, and other ones I did not. I did that intentionally. Typically, when I do this demo, I've got a little bit more time. Question.
Since the schema is not static, when you're looking at a table definition, what is it showing you if it's not static?
The table definition is static when you're using it. If you make a modification to it, you restart the instance, and then when you reconnect, you'll see a new schema. So if you build something statically on top of a schema, don't change it. Once it's been built and deployed into production, create a new one. It's milliseconds. You're talking about generating a new YAML file. It's metadata out.
When you create a new collection, you're just creating a collection. You're not really defining.
I did nothing from the MongoDB side other than point to the database and generate a YAML file, or DRDL file. If I have, let's say I've got multiple schemas, or I want to build multiple schemas based on organization. So I have different user groups inside of my organization. I can build different YAMLs specific to each one. And then when they connect, this is all they're going to see. They'll have a different view. Speaking of views, we actually have views built into MongoDB as well now.
The confusion is that it is a schema, the collection is a schema-less thing, right?
Correct.
So, and all these reporting tools need to have a schema, fixed schema to work with.
Yep.
So that is the issue here. So that is what.
That's why we made it very easy to generate new DRDLs. You can generate those at will. So you can have multiple DRDLs per collection. Is there a limit, Craig? No limit. Okay.
Yeah, but if the underlying schema changes, then the DRDL is no good.
The underlying MongoDB
Yeah,
schema?
MongoDB schema. Because it's a collection, it's not static. Right. The attributes.
But it's generated.
But
from
you can
your
generate a
application.
new DRDL. So you can keep the existing one. Remember, anything that you've generated is based upon what you have in your collection today.
So if you change anything in the collection, you
There has to be some change control.
No. You create a new DRDL for different
Plus
views.
if you're using
Let's say you're adding
then
new
you've got
fields.
your static.
So then would the old DRDO work once the scheme is changed, so you can still run it?
Yes,
And it still work?
yes.
as far as you have not removed something, as far as you have not removed any field from the document,
If you remove fields from the documents,
that's where probably you will not find.
why would you remove fields?
Wait, that was my question. What if you get, because your documents can change constantly, right? You could have a field one.
You can have radically differing documents within the same collection for sure.
Right.
And that can affect the way your DRDLs are built.
Right.
Yeah. Let's table this one. We'll do a sidebar on it.
Yeah.
Need to cover this real quick, and then we'll follow up. Because there's a lot of, I can see there's a lot of questions, people are trying to wrap their mind around it. So, all right, connector for Spark. This one's going to go real fast because I'm like out of time. So Spark, who's using Spark? I know some people here are. William, you using Spark?
Yeah, every day.
You are my hero. So Spark is a framework for doing predictive analytics, machine learning, and it can run natively on MongoDB. You do not need Hadoop for Spark. You can make each node inside of your MongoDB cluster a worker node for Spark. You can work with data frames. You can work with RDDs inside of MongoDB. You do not need to deploy an HDFS cluster for Spark. That being said, if you've already done that, we have a Hadoop connector too.
We have a connector for that.
We have a connector for that. So there's all kinds of really interesting things you can do with Spark. What most people use it for is predictive analytics, machine learning. It's excellent for that. You can do the exact same thing using Python and use PyMongo. Depends on how you want to do it. I like using PyMongo because it's easy. Python is easy to pick up and use, and it can do all the same stuff. It takes less infrastructure. It's up to you. What does Spark look like? Not pretty. That's what it looks like on the left-hand side. That's Scala against flat data sets inside of Spark. Over on this side is a JSON representation. Machine learning over JSON is taking off big time because of the flexibility in the schema. If you've ever built an ML model before, using a relational data set, it stinks because it's static. What happens when you have information that has ascendants and descendants and siblings? Ragged data, which means you have to set this massive data set because one person that you're looking at from a demographic perspective has 14 siblings. One out of maybe 100 million that you have. So you have to have all these columns out there now. You have to build your model on top of that. It's garbage. It's a lot of work on data definition language and building out the static stuff when you don't need to do it. If you do it over a dynamic schema instead, it just picks it up. So it's really taken off. Demo on this, go here. I was going to show you the code behind it, but what it is, this site right here, seriously, you guys can go to this. We've got demos for everything, so if you want to learn more about faceted search, here's our fast book. Maybe I should move this. So you can see it. There we go. So you can see we've got faceted search built in. So an essay, like myself, I didn't build this. Some essays that are better than me. This platform allows you to connect using a browser and play around with the functionality. It tells you everything that's built into 3.4. So faceted search, text, if you want to know how to do graph queries. There you go. Spark integration's right here. Last thing I was going to show you was the actual code behind it. It's not that interesting. But if you want to see it, I can definitely show you offline. Questions? Yes, question.
So the work that I'm doing a lot is in order to have models, we're using Mongoose, right? Mm-hmm. So do you all have a model framework?
Do we have a model framework for machine learning?
No, just for Mongo in general, right? Obviously, your files can change and stuff, but Mongoose's models allow you to kind of define what you're expecting.
So some predefined, like canned schema definition for certain use cases. None that I've seen published by us. I have seen quite a bit out in the community.
Right.
So you go to GitHub, and you'll see a ton in Git.
Yeah. Okay.
specific to that. Nothing that's been officially built and sanctioned by MongoDB. Yes, question?
How does Mongo support, like, if you want to do a row and column security, for example, someone in a specific business unit can see.
That's a good question.
Sure.
Yeah.
Security question. All right, so how do you secure MongoDB? 4 things. Authentication. You can authenticate using Scram-Shell 1. You can do LDAP authentication. You can do Kerberos authentication. You can do X509 authentication. That's who are you? Can you connect? Authentication, authorization, role-based, or role-based access control. If you know RBAC from Oracle, SQL, MySQL, any other relational database that's ever been built that has security built in, same concept. You have roles. Roles have permissions. You add users to roles. You don't give permissions directly to users. Encryption. So in flight, it's going to be TLS 1.2. At rest, AES 256. And then auditing. We can audit everything inside of MongoDB. Who logged in, what they did. Yeah, basically that's it. That's really all you're going to audit, right? And you can output it to several locations. How do you secure collections and documents? You use roles that have permissions at certain levels. So you'll have database roles, you'll have collection roles. You can go down to field level redaction. So based on what role you're in, can you see a field or not? We have field level redaction, absolutely.
So that's handled by Mongo, not the application.
Correct, it's handled by Mongo. Right. If I were to redact based on your role, let's say I've got a role and you're in one role, I'm in a different role. My role, I can see the data that's in the field. Your role, you cannot. When you open the collection, when you open the docs, the field just doesn't exist. It doesn't show up. Yes?
Going on that, can you redact an entire document based on it?
Can you redact an entire document?
In a clip?
No.
Not entire row level security?
No, because the thing to keep in mind is your redaction is based on a definition of fields. Documents can be radically different within the same collection. So you could theoretically build a redaction that says these fields based on your role, but do you know every single document has that same schema? Yes?
I accidentally deleted a connection. Can I roll back on it?
I accidentally deleted a collection. Can I roll it back? Do you have a backup? Do you have the op log? No? Sorry.
That's all right.
Sorry.
If you did.
If you did, yes. So back up your databases. Yes.
Do you have column encryption?
Do we have column encryption? Encryption at no, we do not. Field level encryption, no. Or document encryption, no. It's encryption at rest for the entire instance.
So if all the documents can be so radically different, I could just throw everything in one collection, right?
Yes, you could, theoretically. Question, documents can be radically different. Can you throw them all in the same collection? The answer is yes.
Would that make, I mean, is that recommended though? Or?
No, it's not recommended. Organize it. It's a logical organization, is what it is. And the thing to keep in mind is, do you have huge sets of data? If you have huge sets of data, you're starting to get into billions of documents, and those are large documents. You may need to consider sharding. Sharding is at the collection level. Okay? We can still join across collections. There are different ways to do that.
So I have a use case. I have these really big XML documents. Is there any way I could sort of index those, or do I have to strip them out and store them in the document?
Is there any way to, so the question, I've got a bunch of XML documents. Is there any way to load them in MongoDB and index them and read them? Or do I have to strip them out and load them as JSON? You can do the latter. You can do the former if you use GridFS. So you load those files inside of it. They're binary files. You would load them as binaries in that instance, and then you can actually index into them. You can query them. The files will be chunked up. So there's some cool things that you can do with GridFS. But I gotta. I have to hand it over.
Yeah, we have to. We're running a little bit over time, but
We're a little over. I'm gonna be here. All you guys, if you're still here, if you have questions, come find me. I'll be happy to answer. Okay?
thanks, Matt.
Thanks.
Marks, you're up.
There's the URL of it.